Hi students, welcome back to the class. Today's topic adaptation in hydrophyte. Adaptation in hydrophytes. Okay, so hydrophytes plants having some of the special characters, otherwise adaptations. Today I am going to explain this adaptive natures of hydrophytes. There are few characters I am going to explain to you. The first one, submerged parts of hydrophytes. Submerged means the parts of the hydrophytes having covered with the mucilage. The mucilage means one oily substance or sticky substance present over the plant body. So this oily substance help to the plants for decay, prevent to decay. So it is very helpful for the plants to prevent decay. That's why the hydrophytes, submerged parts of the hydrophytes having mucilage. Second one, the roots. The roots of hydrophytes either absent or poorly developed roots present in the hydrophytes plants. So, in the case of some poorly developed roots having the very small, otherwise very less root hairs are present. I hope all of you know what is the importance of root hairs. The normal plants having the root hairs help to absorb the water nearby the surrounding. But this type of plants, the hydrophytes always leaving the water. That's why they now need the root hairs. Okay. And next one, the stem of hydrophytes. What is the nature of hydrophytes and the stem of hydrophytes? It is a spongy stem and the flexible. What is the reason for this is flexible and spongy? First one, it helps to float. Second one, the sponge having the spongy type or flexible, they are having only one reason. That means they are having number of air spaces or air cavities. That's why that's having the spongy and the floating and flexible in nature. And next one, the leaves. The almost all hydrophyte plants having thin leaf and small in size and the linear or ribbon type. So this type of plants leaves help to least resistance. So that's why they help to float the surface and live properly, survive properly. That's why the plant leaves having thin, small and linear or ribbon type. Okay. And next one, the large aquatic plants. Okay, that means lotus, etc. They are having the circular leaves, large circular leaves. So it is also float the surface of the water having oil content, oily surface. So this oily surface help to float the water and help to decay. Means prevent to decay. Oily surface. For example, in the rainy day, the water falls towards the leaf surface. What happens? That oily surface help to fall down and easy to escape the heavy weight. Okay, that's why these oils help to the plant leaves for the leaf long. And next one, the certain parts are solid for store air. For example, one plant, okay, that's next one. Certain parts are solid type. Okay, so they're having the large air spaces or air cavities for help to float. So for example, the water hyacinth. It is a one type of plant. So some part of the plant having bulged or bulge type. So this bulge type, that portion having large air space. This air space or air cavity help to float and move according to the water current. Okay. And next one, the tissues. The plant tissues, the hydrophytes, their tissues is a very specialized tissue. That means that the tissue having iron chyma. Iron chyma. So this iron chyma help to plant float, otherwise buoyancy. This help to buoyancy. And next one, the phloem or food conducting tissue is well developed. So the hydrophytes plants in the phloem or the food conducting tissues are well developed. For what? This also store the food for the next days. Means it's next levels. That's why the phloem is very well developed, or food conducting tissues are very well developed. So these are the basic features of hydrophytes, otherwise adaptation in hydrophytes. I hope all of you understood this topic. Thank you.